Okay, so it's Friday. It's the last day of the 6 weeks. Bless you. Hope you all are having a good week. We have 7 more weeks of school. We have, let's see, how many more weeks until the AP exam? We have our AP exam May 18th. Quite a bit of time. 1, 2, 3, 4, 5, 6. The 17th, not the 18th. We have 6 weeks until 6 weeks. 1, 2, 3, 4, 5, 6. Yeah. The 17th is the first day of review for final exams here at Memorial. So the next week after that is already the last week, finals week. So we have 6 weeks until. That's actually 5 full weeks. It's on the 6th week where we take our AP Stats exam. So I haven't checked to see how many of y'all responded to the survey that I have on Google Classroom, which you need to respond to. Mr. Rios needed that last week. Mr. Rios being one of our testing administrators. The other one's Miss Elizondo, I think is her name. She's new this year, I think. If not, she was here last year, and that's bad if I don't remember. But yeah, that needs to be submitted as soon as possible because that gives our testing office the numbers necessary to plan for AP testing. So that tells him how many classrooms he needs to reserve, or if the gym's good enough, how many teachers he needs to assign testing duties on that day and stuff like that. So make sure you guys are submitting that. So if you know you're going, well, either way, if you know you are or not coming in person, in face-to-face to take that test, you need to let us know. So that's something we need to know for logistics purposes. So otherwise, there's a big mess if too many people show up or more people show up than they said they were going to show up. And we need to plan, or we need to like take teachers out of their teaching situation into a testing situation, things like that. So make sure you guys turn that in as soon as possible. Okay, so this is the very, very last lesson for the year. So this is the very, very last one. So we're done with Unit 11, which is the last unit of the course. And then from this point on, so starting Monday, review, review, review. So a lot of testing review. So usually I finish around this time, beginning of April. I give a mock exam. I'm not going to be able to give you guys a mock exam because those things are too big. And online, it doesn't make any sense. So we'll just practice with AP material, but together as a class. And maybe if things change between now and the time that we take the real exam, we'll have some something that I could do maybe as a mock exam. Those of you that are here face to face, I might do something for you guys to practice on your own. But we'll see. So mock exams are great, but it's not the end all be all thing that prepares you for the actual exam. It's good to see like how you would score beforehand on an actual exam, but it's very tough for me to do that to where you guys don't actually look stuff up or help each other out and have like an honest attempt at a AP exam because you think it's for a grade and it's going to negatively affect you if you don't do it or if you don't do well, things like that. So it's hard to like convince you guys not to cheat. But either way, so number one, have you experienced a sudden flood of memory when recognizing a song from your past? The article Plink, Thin Slices of Music, Music Perception, which is an actual article, journal, music journal, 2010, describes a study of this phenomenon. The investigator compiled a list of songs from Rolling Stone magazine, that's Billboard and Blender, lists of songs plus some recent songs familiar to college students. Nowadays, when you're looking at like chart-topping songs, Spotify's probably got to be added onto the list because that's also a good indicator of what's actually popular amongst people. So how many plays on Spotify things are getting. So that's got to be modified, but that's back in 2010. That's well before the rise of Spotify. But either way, most of these students had musical training, and they listened to popular music for an average 21.7 hours per week. So after hearing 3 short clips from a song, only 400 milliseconds in duration, so it's not even a second. So that's less than half of a second. So all they do is play about a half of a second. Can you recognize what song that was? So the students were asked in what year each of the songs was released. So not even having to know what song it was, maybe based off of just the way it sounded, what year was it produced or released? The accompanying table shows the actual release year and the average of the release years themselves given by the students. The actual release years ranged from 1965, starting with Beatles' Help, which is an old song, 2008, well, not very, very old in the grand scheme of things. There's been music way before that. But 2008, Katy Perry, I Kissed a Girl. So that's the latest song that was actually played in this 2010 study. So that's a really old song, actually, 2008. How old were you guys back then? Like 7 years old? Or 5?
5.
Yeah, the wrong math in my head. Yeah, because we're already 21. So yeah, that would have been 5 years old. 5, y'all would have been about 5 around that time. I'm not gonna say how old I was at that time. Old enough. But either way, 2000. No, I wasn't in high school. I was in college already. Let's see. The researcher investigated whether there were a relationship between the judged and actual release year for these songs. So are people good at predicting? If they were good at like finding out what year that was, then those should be pretty close. The judged year and the actual year. And it looks like they were pretty close. That's a fairly strong linear and positive relationship. So the people in the study were somewhat close, decently close. But then again, that's kind of wide. That looks like a 40-year gap. So maybe not. We'll see. Minitab output and graphical displays for a linear regression analysis is given below. This is what an AP exam question would look like nowadays because they're not jerks as much as they used to be. They'll give you a lot of the information already, and they'll also give you the graph for the most part. So if they wanted to be really mean to you guys, they wouldn't give you the graphs at all and make you draw the graphs on your own, which I think I did that in the second problem. But in that second problem, I'm not gonna draw them all and have you draw them. We'll just look at the calculator, and just from the calculator, we'll just go ahead and reason from it and not have to actually draw the graphs themselves, because you don't really have to anymore. Most of these questions, and the ones that I've seen in the last 10 years, they give you the graphs if they give you a question like this. Okay, so letter A, state the hypotheses that are used for testing whether there's a relationship between the judged and actual release year. So is there a relationship between those two variables? Because they're both numerical, drawn on a scatter plot. What they mean is there a correlation? So yes or no. So that's what we're trying to set up. Either there is a correlation or there isn't. Now, the way that we test if there's a correlation or not, if there's a slope that's not 0. So if the slope is 0, then that means that the correlation is 0. So if R is equal to 0, then B is equal to 0. And the other way around, because there's a formula that relates the two. B is equal to R times SY over SX. That's the formula for B. So if either R or B is 0, so is the other one. That's a mathematical fact you could check. So if B is 0, then R is going to be 0. If R is 0, it's because B is 0. Okay, so the way that we set this up is null, beta equals 0, not B. B is just the, what's it called? That's the sample value. Beta is the population value. And I'm recording. I just had that ugly feeling in my mind that I wasn't recording, but I think I did. Okay, so either way. Null hypothesis is beta is equal to 0. Alternative hypothesis is the beta is not equal to 0. So notice I erased the null because I need to actually define what beta is. Beta is, so I have to interpret the slope. So that requires a bit of a big sentence. It is the expected, or the average, you could say. Average is probably good. The average change in the actual release year, because that's the y coordinate. Actual release year is the y coordinate. And the judged one is the x coordinate. So the average change in the actual release year for every 1 year increase in judged year. That should be good. So where am I getting that from? Previous handout, you might want to take a look at that because I was too lazy to actually reprint all that information. Or maybe it's, no, I did. I wasn't lazy enough to not reprint that. So let's see. The expected change in the y variable for a 1 unit increase in the x variable, I forgot the population, equals to 0. For what type of people were these? Students, 23 college students. So for all college students, I'll just put college students. And that's supposed to equal to 0 because we said beta equals. So the slope is supposed to equal to 0. The null hypothesis means they're not correlated. And then the alternative is that they are correlated. There is a relationship. So in order for us to conclude that there is a relationship between those two things, which I think we will, because the data look pretty strong. So we would say there is a relationship if we reject the null hypothesis. So rejection of the null hypothesis will allow us to conclude that there is a relationship between those two variables. So if we reject the null, then we will conclude there is a relationship between those two variables. Letter B, name the test that we're going to use and then check conditions for inference. The name of the test is a t-test for slope. So we're conducting a t-test. Wednesday we did t-intervals. And intervals is just a formula. You take B, add and subtract margin of error. And the margin of error formula is pretty simple. It's whatever t-score value you have times the SE for the slope that the calculator gives you, which they've already calculated it for me. So sometimes they have SE coefficient. Sometimes they just write standard deviation. Those are the same thing. So which coefficient do we want? Constant is A, actual release year is B. Constant is always A, B is always the second one. Don't ever forget that. So the one we want is this one. That gives me B. And this gives me SE. So this one here is B. That one there is SE. So I needed those. They also gave me T. The T ratio, 14.82. So the Minitab output gives me all that information. What am I supposed to do? I'm only supposed to check for the conditions. So what are the conditions? There were 3. The first one is a random sample, always the same for every situation. Do I have a random sample of college students? Or at least a representative, what they believe is a representative sample of college students. 23 college students were then exposed to 55 clips. Doesn't say. Most of these students had musical training. So no, these aren't random students. These have musical training. So they know a little bit about music. So these are not random students. So not a random sample. That's the first condition, which failed. So we failed to meet the first condition. What's the next condition? The next condition has to do with the residual plot. So if I look back at the previous handout, the second group of conditions has to do with the residual plot. The residual plot is used to show 2 things. 1, is a linear model good for the data? So do the data follow a linear pattern? So the residual plot will tell me yes or no. Also, is there roughly equal variance? Is the variation against the line roughly constant, the same? So first off, is a linear model appropriate? Looks like yes, because in the residual plot, this is just random scatter. There's no actual like pattern. So it looks like it follows that linear trend. Second thing, do we have roughly constant variance?
Yes.
Yeah, it kind of looks like it. So there's like a rectangle that you could draw those points in. So if it's just rectangular, everything all parallel, then it looks like it's roughly equal variance. So residual plot shows linearity. And I'm going to say equal variability. Check mark on that one. So at least the data look nice. That's the second condition. This is not coming from a random sample, so that's not going to be good. Third one. We look at the box plot. What the box plot shows are how far away each of these dots are from the line. So it takes only the one-dimensional distances of each of those dots on the residual plot, just the vertical distance. So it's looking at all those differences, and it's only graphing them on a one-dimensional number line. So this number tells me that it was 7 points below the line. This one all the way at this end is 9 points above the line, roughly. So that's all that means. So if this looks fairly symmetric, centered at 0, then that third condition is going to be good. So the, what's it called? The box plot should have rough symmetry, no outliers. And that one looks perfectly fine. It is fairly symmetrical with no outliers. Box plot is fairly symmetrical. With no outliers, check mark. So the first one was no go, but the other two were okay. So at least the data look nice, but the data aren't coming from a random sample. That's a bad thing. So we may or may not be able to, now I could possibly make inferences, but only for the population of students that had similar training to the ones that were in the study. So if, let's say, for example, if these were all music majors, then we could say it's representative if they said it was a random sample of music majors, but no other type of student. But they didn't state even that it was random. So I don't know. Letter C, calculate the appropriate test statistic and p-value. Well, they gave them to me. I don't have to calculate them. T is 14.82. That's under T ratio. So T, otherwise it would have been this formula. T is equal to B minus beta divided by SE for the slope. That's the formula for T. It's always observed minus expected divided by standard deviation. So observed is the sample B. Beta is going to be 0. And then you divide by whatever the standard error is for the coefficient. So you can calculate. B is given 0.52299. Minus the hypothesized beta value is 0. Divided by standard error for B. That is the standard deviation, or the SE for the coefficient B, 0.035283. 0.35283. You can put those in your calculator, but you're going to get this value. T equals 14.82. So you can verify it's the same thing that's already there because it already did it for us. Degrees of freedom. Y'all tell me what the degrees of freedom are.
(22)
Or 21 and 22, which is correct. This is for bivariate data. It's n minus 2. Remember from Wednesday? Yeah, n minus 2. So I think it's 21. So 23 minus 2, that's what you got to remember. So it's always n minus 1 except for the scatter plot situation. So if you're working with a scatter plot, two-dimensional data, bivariate data, it's n minus 2. In any other situation, there's a minus 1 some way, somehow. Either it's the data points minus 1, number of categories minus 1, or the two-way table, number of rows minus 1 times number of columns minus 1 multiplied. But in this situation only, it's n minus 2. So 21. And they already gave me the p-value, so I don't even have to go to the calculator for it. But we'll double check. So they already gave me the p-value, and well, they kind of didn't. All they said is it's less than 0.000 something. So I might want to go to a calculator and find out for myself what that is. Gives me an excuse to show you more calculator stuff. So let me start the calculator, come up with some weird thing to talk about so that this time in between the calculator, like opening up, isn't so awkward. It isn't open yet. There we go. Okay, so anyway. Calculator. Menu. Now what we're doing here is we're finding p-value. P-value is probability. Probability is the area under a curve. 0 right down the middle because we're talking about a t-value. Z and t are centered at 0. 14.82, which is a very, very large number to the right. So it's very far to the right. And where's beta? Right here. The alternative hypothesis, tells me how to find the area. What do we do in a not equal to situation? Y'all remember? Yeah, we'll take one extreme. So one extreme would be to the right. What do I do with that one? Multiply by 2. So whatever that is times 2. So y'all remember, for a not equal, there's 2 ways we can be not equal, either significantly greater or significantly less. So that's two-tail, negative 14.82. And this area to the left also gets added onto this other one. That's why it's multiplied by 2, because it's one of them multiplied by 2. They're the same area because it's symmetrical. So I can erase that. Just do one of them multiplied by 2. So we'll figure out what that is in the calculator, which is going to be very, very close to 0. If the calculator is fussy and doesn't have enough RAM, it's going to just tell me it's 0. So probability distributions, CDF for area. Lower bound is 14.82. Upper bound is infinity. Just a lot of 9s, and that's going to be good enough. Degrees of freedom, 21. Press OK. And it gives me an answer, 6.78823 times 10 to the negative 13. That times 2 will give me like 1 point something times 10 to the negative 12, which is extremely tiny still. And I forgot the 2. 1.3576 something something times 10 to the negative 12. 1.358. That's these two combined. And they were added. So that's the entire p-value. So the p-value equals 1.358 times 10 to the negative 12. So that was already after I divided by 2. Any questions on any of that? Hopefully nothing too difficult. It's just remembering a lot of these little details. Hardest part, in my opinion, is checking the conditions. In most situations, you don't have to. Sometimes they will ask you those conditions, like in a multiple choice question. So they might describe a study, and they might ask you a question that asks, like, why can't I use a t-interval properly? And there'll be a bunch of reasons in the choices, and one of them has to do with one of the conditions where the conditions might have failed. I've seen that before, which we'll see that later. We'll do a bunch of multiple choice questions later, because this time this test is going to have a multiple choice section. It's not going to be only free response like last year. Okay, so there's the 4-step procedure. So we didn't actually finish that entire problem. There should be a part D there that asks for conclusion. So we'll look at number 2, and we'll try to finish this all the way. And I'm going to need that calculator again. And I'm more than likely going to have to plug in data. So I'll have to open up a list and spreadsheets page, and then eventually a data and statistics page to take a look at the, yeah, go ahead. Data and statistics page to look at the scatter plot, the residual plot, and then the box plots. So we'll look at number 2. Number 2 states, the accompanying data on 6-year graduation rate, that's in a percentage, student-related expenditure per full-time student, and median SAT score for a random sample of the primarily undergraduate public universities and colleges in the United States within, let's see, enrollments between 10,000 and 20,000 were taken from College Results Online, the Education Trust. So median SAT for these students that went in, the expenditure, and that's per full-time student. I'm thinking that's per semester or per year. That may be per year. And then graduation rate, like how many of them in a percentage are actually graduating. That's very interesting. So you're seeing the more expensive schools have a higher graduation rate. This one looks like the least expensive school, 22% graduation rate. But that's not 100%. Like this one here is really high, 6382, but a really high passing percentage. But generally speaking, we'll look at that on a scatter plot. Run a test for the slope of the linear relationship between graduation rate and median SAT score at the 2% level of significance. So are they actually related? Graduation rate, median SAT score. So if you're going to take SAT score to define how well a student is doing, or performance, or an indicator of future performance, is that going to be a good predictor of generally your graduation rate as a campus? So like if your student body has a generally higher, on average, median SAT score. So median is like a center. It's like an average, but it's not the average. So if your kids have a higher SAT score, you're going to have a higher graduation rate. That's the question. So we would expect that to have a positive relationship. So we'll see how that works. So we'll start off with the null hypothesis being beta equals 0. There is no relationship, no correlation between these two. So these two variables aren't correlated, is the assumption. So we'll assume no correlation. So first off, I have to define what beta is. Beta is the slope, which means it's the rate of change of y with respect to x. So this is the average change in graduation rate for every 1 point increase in median SAT score. For full-time students. Full-time college students, we'll say. Again, if you want to go by a template, it's the average change in the y variable for every 1 unit increase in the x variable for whatever population you have. That should usually work. And we're saying no correlation, meaning the slope is equal to 0 for the null hypothesis. Alternative, not equal to 0. Now, there's a couple of things you could do. In this situation, you might be free to change that not equal to 0 to a greater than 0. If you expect that to go one way, like the higher the SAT median score is, the higher your graduation rate, generally speaking, then you're allowed to make that greater than 0. But just for the sake of consistency, you can go with not equal to 0, because it can go both ways. Maybe it could be the exact opposite. Maybe your graduation rate is better for some reason. But either way, where it's not super obvious, just put a not equal. So that's the first thing. Second thing, we'll check conditions. Now, in order for me to finish all the conditions, I need to have the graphs of the data. So let me see if I can try to plug all that stuff in, move this up a little higher so I can see both at the same time. And I'll use a keyboard for that because it's easier on a keyboard. So call that SAT and then grad. Median SAT, graduation rate. And it's kind of hard when it's horizontal versus vertical. So I got to make sure I don't repeat what I did on Wednesday and take like 50 different times to correct all mistakes. 1045, 990. So for that reason, I'm going to speak what I'm typing. 970, 980, 1080, 10. I think that's 25. 35. See 9? There's supposed to be 9? I guess. The graduation rate, 49, 33, 37, 49, 22, 38, 39, 52, 53. Those are the values that I got to have plugged in. What next? We're going to go ahead and graph those. So data and statistics, we'll go ahead and graph a scatter plot. So SAT versus graduation rate. Now, what do we think? How would I describe that if they asked us to describe just what's on the scatter plot? Linear?
Correlation?
A weak linear. Missing one thing. Positive. So it looks generally positive. As x increases, y is generally increasing. I would probably say that that's moderate to strong, not weak. So let's see why. If I go analyze, regression, linear, a plus bx, those are fairly close to the line somewhat. So we could take a look at the regression just a little bit, but I'm going to do a residual plot. So since they're not asking for our opinion on whether it's strong or weak, we don't have to worry about it. All I care about is if it's linear or not. But you guys are okay with saying that it's linear for sure? Not non-linear? Yeah, so that's all I care about, if it's linear or not. Residual plot should show that it's fairly linear. And that should just look like random scatter against the line. And it basically does. Okay, so that's the scatter plot and the residual plot. So I just need the residual plot to say if there's linearity and equal variance. Would I be able to say that that's roughly the same variation all the way throughout, randomly speaking? I don't see anything crazy where like it funnels. So nothing too crazy, because there are data sets where that happens, but this is not one of those. Plus, it's a small data set anyway. It's a small sample. So what I got to go to next is a box plot. So I'm going to do another data and statistics page. Only on the x variable, I want the residuals. Stat.resid is where you find them. So that it defaults to a dot plot, so I have to change it. I mean, if you want to draw the dot plot, you could, but I wouldn't. I would draw a box plot because it's much easier to draw a box plot. Literally 5 points. Mm-hmm.
This question is exactly as it's stated.
Mm-hmm.
Do we have to draw a graph?
Yeah, you have to draw both the residual plot and the box plot. So the question was asked in class, if the problem on the AP exam was stated the way it is exactly here, do we have to draw those graphs? Yes. It's happened once, but back in 2001, a long time ago. And since then, there's been at least 2 or 3 more questions like this. And in each of those times, they give the graphs. So in this case, I don't know why I didn't give the graph. Well, I didn't actually. I'm literally repeating this lesson from last year. And I think that was a repeat from the year before that. Actually, no. Last year, I didn't teach this because it wasn't tested on the AP exam because they cut us off before this. They didn't even test chi-square last year because of the COVID-19 situation. So they assumed, on average, where should you be at spring break? We'll test up to there. And that cut out chi-square tests and this stuff. So last year's students had an easier test compared to this year and my year before that. So this will be on the test. So this is my lesson from 2 years ago, 2019. Who was in my class 2019? 2019 was the Zach Moore, JL Gomez year. I had a lot of kids that year. I had like 25 kids. I actually have more kids this year. This year I have 36. Okay, so either way. The test, it's a t-test for slope. Good enough. First condition, is this a random sample?
Yes.
Random sample of the primarily undergraduate public universities, yeah. Random sample given, check mark. Then we have 2 conditions that stem from the data itself, like what they look like. So we talk about the residual plot first. A residual plot shows linearity and equal variance. And I'm not given a graph to back that up, which is bad practice. I mean, you can clearly see. Oops, and I started Acrobat, I think. Did I? No. And equal, I'm going to say variability, because variance is something specific. Variability is a general term. Variability is synonymous with error, residual, stuff like that. Check mark. Third thing, box plot looked perfectly fine, I think. I didn't talk about the box plot, but box plot is okay if it's roughly symmetric with no outliers. And it's roughly centered at 0. So the residual should be centered at 0 anyway, because of the least squares regression. It's going to end up being close to 0, that box plot, or the center of the box plot. But it's roughly symmetrical, no outliers. Box plot of the residuals.
We have to show the graph. We show the residual and the box plot, but we show like the graph also.
Okay, so the question is being asked in class. Do I have to show 3 graphs? So box plot needs to be there, residual needs to be there, but does the scatter plot, the original one, need to be there? No. Residual's good enough with the box plot. But you don't have to draw the first one, the scatter plot. So no, you don't need all 3 graphs. It's just the 2, the residual plot. Yeah, and the box plot of the residuals. Box plot of the residuals is roughly symmetrical with no outliers, and my no looks weird. Still, but whatever. No outliers. Check mark. So you're good to run the test. So what does the test look like? T equals observed minus expected divided by standard deviation. That is the formula for the t-test for slope. So I got to do some work to find out the value of B. What's the value of beta? 0. Very good. So it's literally just B over SE. You can cut straight to that. B over SE, and that's good enough. It's the ratio of B to the standard error. So how do I find those 2 values? We remember I have to go back to a calculator page, which I don't have open. Well, I think I do. Page 1, but whatever. I'll just start another one. I go to a calculator page, and because you're running a test, you could just go straight to the test. And all the tests and intervals can be found in the same place under statistics. There's confidence intervals, and there's stat tests. Same thing for, what's it called? 84s. If you're using a TI-84, you press the stat button. There's a stat button, and you'll find on the top stat tests, and you have intervals and tests all together in the same place. So stat tests, you want a linear regression t-test. There's a multiple regression, which we don't cover in multiple regression, or ANOVA. ANOVA is interesting, but we never get to that. Okay. My X list was SAT. And its graduation rate, that was the Y variable, the response variable. Alternative hypothesis, beta and rho are not equal to 0, as opposed to greater than or less than. So don't get psyched out by that rho being there. How do I know that that's a rho? That's another Greek symbol. So first off, beta and B are associated. B is the English letter B, beta is the English letter B. Actually, B is the English version of beta because Greek was first. All right, so same idea. R in English is the same as rho. Rho looks like a curly P. So that is it looks like a P, but it's an R in Greek. So because sometimes in some textbooks they don't go with beta, they go with rho, correlation directly. In AP Stats, we go with beta to indirectly state that there's no correlation. Same idea though, but either way, you set it to not equal to 0 because that's what we're going with. Press OK. There's SE and B, so B is 0.1524. SE. SE slope at the bottom, not the little s. That's not the one we want. We want SE slope, 0.0528. Divide those 2, and you're going to get T, which T's already given. T's given up close to the top, 2.888. T's already there, so I don't even have to plug that in. 2.888. The only thing I hate about this particular calculator function, it doesn't tell you the degrees of freedom. Or does it? Yeah, no, I was just talking out of like thin air. It's the intervals that doesn't give you T. Y'all remember that? The one we did on Wednesday didn't give you T, and you had to find it yourself by doing inverse T. That's the one that sucks. This one's fine. This one gives you T. And degrees of freedom. Degrees of freedom 7. That was 9 minus 2, which is 7. Those are 2 separate pieces of work. Kind of looks like I was saying those were both equal, but they're not. P-value. I don't even have to find it using TCDF because it's already there too. 0.0234. That is literally step 3, where you do all the math. All the math is done by the calculator if you type in the data. The part that sucks is typing in the data, and you got to make sure it's correct. But once you have the data done, then you could just have the calculator do this for you really quickly under stat tests. Now, how do I finish this off? We still have about 8 minutes left, which is good. So either way. So how do I finish that off? Same as any other test. Since the p-value is less than whatever alpha, is that small enough for me to reject? Oh, I didn't read all the problem, did I? Oh, I did, but I forgot. 2%. So with that 2%, because they're being jerks and they're making me use their alpha, I got to use that one, 2%. Am I failing to reject or rejecting? Failing to reject because it's bigger. This one's bigger. Since the p-value, since I've already written what the value is there, I'm just going to go ahead and say that since the p-value is greater than or equal to 2%, since it's greater than or equal to 2%, we fail to reject. You reject when it's smaller than the alpha that you select. We fail to reject the null hypothesis. There's no reason for us to believe that they're not correlated. So I'm going to assume still that it's not correlated. There's not enough evidence for us to go ahead and assume or conclude that there is a correlation. So there is not enough evidence. Now, if you wanted to be like a, I don't want to say try hard. If you want to be like if you want to be a bit extra, there's not enough statistical evidence. But this is good enough. Not enough evidence to conclude that there is a relationship between. You can go as vague as using the word relationship, as opposed to there's a slope or correlation. Not enough evidence to conclude a relationship between, and then I got to state what the variables are. Median SAT score and college graduation rate. Is how we would conclude that test. Yeah, you would also want to continue for full-time college students because that's specific information that is important. You don't want to leave out anything that you think you shouldn't be leaving out, especially on the real exam. Like if I were practicing for a real exam, that paragraph would probably be a little larger. You don't want to say too many things and reveal that you don't actually know what you're talking about. So you want to make sure you give just enough to answer the question, but nothing more than that. Sometimes you'll run your mouth, and that's probably not the best way to describe it. And you'll describe too many things, and sometimes some of those things you say are wrong. They'll take off points for the wrong things you say, even if that wasn't part of the question. But yeah, this should be good enough. Any questions on any of that? That is the last of all the material, but it's also the last, obviously, of the statistical procedures, the inference procedures. What inference procedures are we going to be responsible for knowing? One mean interval test, that's 2. One proportion interval, that's 3. Test is 4. 2 mean interval, that's 5. Test, 6. 2 proportion interval, that's 7. Test, 8. Matched pair, you all remember that one. Interval and test, that's 10. Chi-square goodness of fit, that's just a test. Chi-square for homogeneity, I should write the full word. Bad idea not to. Chi-square independence or association, that's a test. Slope interval and test. How many is that? 14, 15. 15 different inference procedures that we started back in December all the way up to now. That's what we've been concentrating on this entire time. Oh, and then the conditions are different under the situation that you have experimental data instead. But those aren't separate tests. Roughly still the same thing. So those are all of the procedures you are responsible for knowing. You're going to have 2 questions on the free response section of the AP exam, and they'll pick one of those. So 1 year, it might be a 1 proportion interval, and on another question, it'll be a chi-square test for independence. And you have to know. You don't know which one's going. There's no way I could predict because it's pretty random. I can't find a pattern in how they actually, and if I found a pattern, I would tell you guys, and it's going to be these. Make sure you guys study these. But 1 year, it could be a matched pair test and a chi-square goodness of fit. We have to know all of them, all of the procedures. So that kind of sucks. But that's what a lot of the review is going to be for. So we're going to review a lot of that information. I think that's the first thing I'm going to review with you guys. Or I might go in the order of units 1, 2, 3, and so on. So we'll see how that works. We're going to stop it here. I will be assigning our first progress check pretty soon. So that might be maybe over the weekend. If not, no, it's not going to be over the weekend because we're in between 6 weeks. So I'll deal with that Monday. We'll see how that works. So more information on that on Monday. We're going to be using AP Classroom a lot more frequently. So now I got a plan for Monday, what we're doing Monday. And it's going to be something review related. So I don't know yet, and I'll figure it out. I have the weekend to figure it out. But for now, that's going to be it. It's the last day of the 6 weeks. If you guys are missing homeworks, please turn them in. So some of you are below passing, and you could be passing if you have those homeworks turned in. That's not all of you. It's very few of you. But there's some of you in here that need to turn your homeworks in. Please do so. So other than that, let me stop here. Let me stop recording. If I can find the record button there. There we go.